Yeah.
So, hi everyone, this is Robert, your host for today's Analytics and Data TechCast, which will be immediately following after this brief introduction. I'm the CTO of Semantic Web Company. So, Semantic Web Company is developing the PoolParty product suite, which integrates with Oracle, Spatial, and Graph. Today we're going to have a great speaker, Timea Turdeyan, a software engineer from Semantic Web Company. She will speak about and demo about developing an RDF4J adapter for Oracle, Spatial, and Graph with a focus on SPARQL. And after that, we will have a brief Q&A. So this TechCast will take about 30 minutes, including time at the end for questions and answers. So please submit your questions in the Q&A window so we can track them and answer, and they will be answered by the speaker. This TechCast will be recorded and posted on the TechCast page. We will also post the PDF of the presentation on the ANT TechCast page and later share the video on YouTube. So Timea, can you please take over?
Hello, everybody. Can you hear me? I hope so.
Yes, it's fine, Timea.
Just a second. I will share my screen in a moment. And here are my slides for today. Thank you, Robert, for introducing me. As he mentioned, I'm going to talk about a project that I was working on in collaboration with the Oracle A team to bring an RDF4J adapter for the Oracle database, specifically for the Oracle Spatial and Graph. This is me. I work as a software engineer at the Semantic Web Company. And yeah, feel free to tweet about this TechCast. I included some of the hashtags and things you could be following, or you can tweet about in general. My background is as a software engineer. This is what I studied, and I started to work at the company like more than 4 years ago. And this is where I learned all about the world of semantic web. And since then, it grew on me. And I've been trying to push the boundaries to integrate different types of triple stores, for example. This slide is more to announce the fact that our adapter that we developed in the process of the project will be open sourced, but it's not yet ready, available. So the code snippets or the small architecture that I'm showing, are small sneak previews for you. Right, and that brings me to the topic of the TechCast itself and the objective. The RDF4J adapter for Oracle is a larger topic, but today I'm going to focus only on the SPARQL view and what we worked on to make SPARQL available. And I also have a small use case to show what you can do if you have SPARQL available through RDF4J on Oracle. Well, for those of you that are already very familiar with Semantic Web, it's nothing new. These are the standards that we abide by in Semantic Web domain. And of course, everything is in RDF format. And this is a snippet of, a piece of information which is in RDF. This is how it would look like. And then you have, of course, SPARQL that helps you to query this data from the so-called triple stores to be able to then integrate and create beautiful applications. And what makes an RDF, or what makes a store, a database RDF ready, you might ask? It's simple. Your RDF can go either way. It can be based on the Eclipse RDF4J library or the Apache JENA library. So if you support this as in your adapters on top of your database, then we could say that, yes, it's an RDF ready database. And even better would be if you have, of course, a SPARQL endpoint directly on top of the database. It's maybe not a surprise that Oracle actually offers these capabilities since quite some time, and they've been even involved in defining the standards such as RDF and SPARQL in Semantic Web. You can read a bit about it. I have a source, a link here in this slide. Okay, what is there now? What you can use right now is so-called plugins or adapters. You could go to the download section of these plugins on Oracle website, and you can find the Apache JENA for Fuseki, for example, or Protege plugins, and you can download them. They are available for different versions, for example, already for 19C. And this would get you started then to work with the RDF features on Oracle. And that brings me again to the point of our adapter. So we were working in collaboration with the A team, specifically with Derek and Emma, who are from the Oracle A team, to create, besides the Apache JENA and the Protege plugin, also an RDF4J ready adapter. Why RDF4J? Well, simply because you can tap into a new community, into the RDF4J part of Semantic Web community. Then you have a broader pool of skilled developers that know Semantic Web. And also my favorite, then you can use PoolParty Semantic Suite directly on the Oracle database. And we jump right into the technical part. If you already develop and use, so for example, the wide known OJDBC driver from Oracle for Java, then this shouldn't be a big surprise. This is what is also at the core of the new adapter. So on the right side, you would have the OJDBC driver. On the left side, you immediately recognize the Eclipse RDF4J driver, which is known in the RDF4J Semantic Web community. And then the middle part is the one that actually got created in this process. And with one view, you can see you have an Oracle repository class. This is the main class through which you get to connect to the database, specifically to the semantic network that is set up on Oracle. And then through methods such as prepare tuple query or prepare Boolean query and so on, part of the Oracle Say repository connection class, you basically work directly in RDF or with a known Oracle RDF4J way. Right, so let's look at a bit of code. And these 2 lines are the basic configuration points you need to get started. This is not new if you're already familiar with RDF4J, right? This is just creating a Oracle repository like any other repository, and then you get the connection of it. And then the next topic is immediately, okay, how do I, run a SPARQL query? So this is, for example, how it looks like when it comes to how to input the SPARQL query. You see the SPARQL syntax, and this particular one, the last particular one, for example, is a ask query, which would give you a Boolean result back, which you can then work with in the code. Good. And since we got the basics down, let's see what was actually part of this journey. What did we learn? First and foremost, after we have, for example, established the repository and the repository connection, and this is working on Oracle side, calling the SEM API. Maybe this is important for mentioning as well. So as long as there is a SEM API available, this is already part of the OJDBC driver. You can do actions such as Oracle Sale Connection, get bulk update handler, and add in bulk. And this, for example, was added in the connection add method. The connection add method is the typical way in RDF4J library to upload the data set. This particular one is an example for a trig format. And the catch or the difference here with Oracle is that under the hood, this add method actually uses the internal bulk add of the data. And this is more probably for the people who know Oracle better. It gets, the data is added in a temporary location, a temporary table. And then Oracle internally redistributes that and writes it to the actual database. This makes then the connection add method faster. And it's a potential a positive advantage over other databases that don't offer this bulk upload. Okay, other things. In general, to build the adapter, to develop the adapter, we went methodically creating basic JUnit tests. And that meant created JUnit tests around the basic methods that you have available in RDF4J, such as prepare tuple query, prepare the Boolean query, the one that we saw before with the ask query, prepare the graph query, update query, and so on. And all these possible methods with different parameters have been then tested in JUnits properly. Then it's about checking, for example, also if these methods can be evaluated. So we have certain situations where particular SPARQL queries were not evaluating. So this is a JUnit test example. After we upload some trig file, some data, we simply run a select count query, and then we evaluate it, and we expect to get in return a binding set, and then we count basically how many records we have in our binding set. Yeah, and that has to, of course, correspond to the number of statements we have in the upload data in the first to begin with. Typical JUnit test we worked with. Then it went towards the SPARQL syntax itself. So we had to make sure that the count works, so syntax or queries such as copy from graph 1 to graph 2, for example. We also found issue in the coalesce syntax part of the SPARQL query, which is used in a particular way for our use cases, but still production-ready, valid use case. So for example, you have different fields that describe a resource, for example, and you're not sure which of the fields then have text description. So coalesce would then help you to get the text from the field that actually has the text, and you don't care which one delivers you that back. Also, we found out that if your, for example, the description or definition fields contain more than 4,000 characters, what happens on the Oracle side is that that particular field is then stored in a club, what so-called club data type. But if it is more than 4,000 characters, there was a issue. So luckily, working with the Oracle database engineers, we got a patch, which is available for the 18C database, and that solved then our problem. So we could get the proper description, entire description field, even though it has more than 4,000 characters. Yeah, other syntax Spark queries that might have been problematic, if I remember correctly, was also the construct query. And very funny, I think the funniest part was naming the variables in the SPARQL query. So basically the variable names had the same names or the same strings like some reserved words and keywords in Oracle, such as, I don't know, a Stein, or I don't know, whatever other. I have a link here with the keywords, but that's now fixed as well. Okay, another big point that is straightforward for the people who are familiar with RDF4J in code are the bindings. So this is how I would write a proper SPARQL query in code. I have here a select that contains a subselect, and I want to focus on the S and P variables. And then on the last two lines, you have this graph query set binding for the S variable and for the P variable. I basically try to inject in there these particular resources. So it's important that the code gets this right. Not that for some reason it injects these queries, for example, into the S variable which is part of the select, right? So that would be wrong. It has to be part of the where part of the query. Maybe you can say it was straightforward. Well, not for some cases. So this is a valid test case that we have part of the adapter. And that brings me to the next point, the use case itself. Because after a lot of test cases and a lot of work, and besides the fact that a lot of things already work in Oracle, such as the property path, you're probably familiar with it, through which you can build very complex queries, that had absolutely no problem. So to focus on the use case of what you would actually do with this feature on Oracle, let's look at the need that an HR manager could have, simply needing to find specific people for specific skills, right? This is actually not necessarily a problem of an HR manager, but could be also internally if you are looking for team members for a new project that you want to kick off. Right, so usually how it is that the data is in different formats and in different places. So let's say we have an employee database, which is a relational database. We have resumes, PDFs, for example, and we also have some tabular data, Excel as well. An Excel it could be, or it could be XML as well. It wouldn't matter, it's in tabular format as well. So the point that we always start with is to create a knowledge graph. And this knowledge graph is then stored in a triple store or in an RDF graph database. For the purpose of this demo, we took the data sources and we triplified them. So we transformed the data in RDF and stored it. But in production, you would basically just store the metadata or the annotations in the database. So there's no need, for example, to store more than 4,000 characters of the description of the whole CV, for example, in the database. That there are other databases that can handle text better in that way. But for the sake of the demo, we store everything here now in RDF. And for the sole purpose of trying to solve the HR manager's problem with an application, with a search application particularly. We use internally our PoolParty GraphSearch component that basically is offering a tool set on top of a knowledge graph that offers services such as search, similarity, or recommendation. But before we start with the visualization part of the data, let's go a step back and see how we can prepare Oracle database to be able to store RDF data. I'm not going to go into detail. I linked here a blog post that my colleague Emma wrote, and she describes basically the 3 basic steps that you need to make your Oracle database contain semantic network. So first you create a table space, you create a user, and you create a semantic network. And then you're ready to use the RDF adapter, RDF4J Oracle Adapter. On the configuration part of the repository or of the semantic network, it looks very much similar to what you're used to if you're working with SQL developer interface. You have the URL to the driver on the same port as usual, 1521, and then you input a repository ID. In this case, it's an HR demo, but a repository ID is like the semantic network in Oracle. Yes, and then you're ready to connect to the triple store or the RDF part of Oracle and upload data and query your data. And this brings me to the demo itself. So I have here a server that is basically showing the GraphSearch component of the PoolParty Semantic Suite. And it's a dashboard. First and foremost, you have 2 graphs, one that displays the salary bins and one pie chart which displays the programming languages of the records you have. We have only 127 records. In case you're wondering about the images, They are not real, not the real actors that you are used to from TV. We just have the pictures, but the names and the data is all randomized and scrambled. So in case you recognize somebody, yeah, can be. So what do we see otherwise? On the left side, we see what we call your search navigation or facets. And we have language, we have operating system, we have programming languages, research focus, salary, technology domains, and tools. And 127 records altogether. You can paginate through them. We just display 10 at the beginning. So let's say now that I'm interested in the records that contain, or the people that know CSS. So I would drill down on the facets by using the CSS filter. And then you see in the results, we have then 4 personas, 4 people that have this skill. It's very interesting also to mention that these facets are guided through an ontology, basic for semantic web, and it's highly flexible. So if the HR manager comes now and says, hey, I also want to be able to drill down on another aspect, I don't know, like geographic location of the people, then that would be straightforward for me to just add, because the data presented here is highly dynamical and flexible. So I could just get that data from an online source, open source, for example, annotate the content, the CVs, maybe they also mention in their CVs where they are located, and just simply display it on the front end or make it available as a search facet. So now I opened a particular record, and you see they have very nicely presented here the metadata that was extracted from their CV in a nice structured way. And of course, the CSS programming language skill. On the right side, we see one of the other services available for GraphSearch, the similarity. You can have here multiple plugins. You can implement your own algorithm for similarity. Yes, and this is how I would then navigate, for example, more through the records to find what the HR manager needs. Well, in a nutshell, this is the demo. Going back to the slides, I think I also uploaded some screenshots. Last but not least, I want to mention our annual Semantics conference. Our keynote speaker this year in Karlsruhe will be Michael Sullivan. He's even part of the TechCast attendees, and he'll be talking about try not to move the data. Very interesting. If you're in Germany, make sure to check it out. And as well as Emma will be there, my coworker from Oracle A team. She'll be delivering even a workshop on how to build and visualize enterprise-ready knowledge graphs in the cloud. And she will focus, of course, and showcase once again the Oracle RDF Adapter and what cool stuff we managed to do until September. Yes, I also added a few notes of further readings or starting points or demo applications for you, blog posts also from the Oracle A team. If you're curious about the whole topic and what I discussed today, I hope I managed to trigger your interest, because this is what I managed to do in 25 minutes or 30 minutes. And now would be the time for questions, and thank you very much.
Okay, any questions? If you have questions, please post them to the Q&A. Okay, maybe in the meantime, I would like to know which version of the Oracle database do you support?
While developing, we worked with Oracle database 18c. It's in the plan that we update it and check it out also for 19c. I've heard that the semantic API part was changed from 18c to 19c, so we have to see if that still plugs and plays with the adapter. But we're not expecting to have any big issues to make it available for 19c as well. Meanwhile, I also have, I think, 2 other questions in the Q&A and in the chat. Can we have the slide deck? Of course, this will be available online, and you can browse to them and hopefully click on the links and further readings. Is it possible to obtain this demo script? Yes and no. So the demo is actually publicly available, but I have to say it's not stable yet. We have at the moment a problem with latency because the database, Oracle database, is in Frankfurt and my application is in Vienna. I'm located in Austria, Vienna. So there's a few milliseconds lag. That's why you probably already saw that. So let us a bit work on it to make it foolproof, and then it will be ready for everybody to click through the demo. The adapter itself will be available open source, hopefully later this year. So yeah, you can check out the code on that if you're interested in that particular point. Yeah, I don't have any further questions in the chat nor the Q&A.
Okay, then thank you very much, Timea, for this really good TechCast about the Oracle RDF4J integration. And I would like to encourage everyone who has knowledge and expertise in this area to submit to the TechCast abstract proposals. So you can do that at the TechCast website, and we will review your proposals, and the subcommittee will select the best ones, and we will work with you to schedule a future TechCast. Please come back in 2 weeks when we have our next TechCast about what's new in OAC by Dan Vlemis. So see you in 2 weeks, and please share this information with all of your colleagues. Thank you very much for joining to this TechCast, and with that,
Thanks a
we
lot.
conclude this TechCast. So thank you very much.
Bye.
And goodbye.